so today we're going to prove inverses, but simultaneously we're also going to learn how to find the inverse when we're given a function or a equation. So looking at our first one, we've got f of x is x minus 1 over 2, and then its inverse they're saying is 2x plus 1, and they want us to prove this. Well, first of all, to find one, you would just interchange them. So if I want, and this is one way to prove it. So if I want to find the inverse for the f of x one, then I would simply change, just like in a table, we swap our x's and y's. Well, I would do the same thing. I would swap my x and y. Okay, so all I did was take this y and make it an x, and that x and make it a y. Now I would solve for y. First thing I would do would be multiply by 2, and then I would add 1. And you'll notice this inverse right here ends up being g of x, which they're asking us to prove they are inverses. So now I would do the same thing going the other way. So I would take g of x, and this time I would put x equals 2y plus 1. Once again, all I did was swap my x and y's, just like when we're taking and finding the inverse of a table, we just swap our x's and y's. So step 1 would be to subtract 1, and then step 2 would be divide by 2. And now you'll notice I have found what f of x was. So I have just proven that they are inverses. So we prove this by, we swap the x and y, and then solve for y. Okay? So then, now we're going to use composition, which we learned in our last class. So now we're going to talk about, we can also use composition to, once again, prove it. We can't use it to find it, but we can use it to prove it. So I'm going to do f of g of x, which means my Audi function is f of x, and f of x went x minus 1 over 2. Keeping in mind when I'm doing a composition, my outside function, which in this case is f is on the outside. Everywhere there's an x, I'm going to put parentheses. So now my inside function, which is g, I'm going to take that and I'm going to put it on the inside, and that function was 2x plus 1. And now I just simplified the two. So let's see, I would start off, you see these 1's right here, it's going to give me, they're going to cancel out, and I'm going to be left with 2x over 2, and then my 2's will cancel, and I'm left with x. If they are inverses of each other, then your answer is x. Please understand, we already know what the answer is. Our job is to prove it, which means you have to show every single mathematical step. Do not take any shortcuts. So now I'm going to go the other way, and I'm going to do g f of x. Okay? If I do g f of x, that means g is now my outside function. So everywhere there's an x, I'm going to put a parenthesis instead. Now I want to take my inside function, which is f, and I'm going to put it inside. So I got x minus 1 all over 2. So my first step in simplifying this composition would be to cancel my x's, cancel my 2's, which gives me x minus 1 plus 1. Once again, you got to do it step by step. Then I got minus 1 plus 1, which would leave me with x. So in this case, I have proven that they are inverses. Okay? Now, we've got another one to do over here. F of x is x cubed, and g of x is this. So one thing I want to make sure you understand before I go to showing you that. First of all, once upon a time, you might have learned this. You may remember it, you may not. The cube root of 3, the cube root of x, is the same thing as writing x to the third power. Okay? So that being the case, if I do f of g of x, then that means my outside function is f, which is something cubed, and then on the inside, I've got this cube root of x. Well, keep in mind, this is x to the 1/3. Well, when a power gets raised to a power, you multiply these, which would be 1, so it would be x. Now, if we went the other way, we would do the cube root let's see, we would have g of f of x, and that would be the cube root, and then inside we'd have x cubed, which the cube root and the cube would cancel out, and you are left with x. So now let's try it, say we're given a quadratic, okay? So it's saying, it's asking us at this point to take this 3x squared minus 6, and we actually need to find its inverse. Now, the reason its inverse is going to be a function is because we have limited. Remember when we were graphing parabolas, we had decided that it wouldn't pass the horizontal line test, so we had to actually make half of the problem go away, all the way to the vertex. So that's all this statement's doing right here, is it's erasing that half of the problem so that its inverse will be a function as well. So, once again, we're going to flip our x's and y's. So I got x equals 3y squared minus 6. My first step would be to add 6 to both sides. Next, please remember, you can't square root it until you make that 3 go away as well. So I'm going to divide both sides by 3. And now if I want to make that squared go away, just like we've done in the past few units, I'm going to square root both sides. When you square root both sides, you have got to remember your plus or minus. And then if I square rooted y squared, I would get y. So looking at this, what I'm really interested in you seeing is what this is graphed now. So what that's doing. Okay, so I want to graph in our calculator. Start off by pushing home, 1, no. So you're clean on your calculator. We want to do a graph. And we're going to plug in the square root of x plus 6 divided by 3 and push enter. X plus 6 divided by 3, push enter. Menu, window. Hold on, let me check this. Sorry, I must have typed something in wrong. I knew it didn't show up, but okay, so this would be what my graph looks like. Now this was just the plus. So keep in mind we have a plus or minus, so now I need to hit tab and I need to do negative square root, and I'm going to do x plus 6, close my square root, divided by 3. Okay. So the catch is what I want you to remember when we originally graphed these. Well, we made this whole left side go away, correct, by restricting it. So if we were to see this graph, this bottom part of the graph is the part that we made go away. So when you write your final answer, f1 of x, f inverse of x, you're not going to do the plus or minus. You only want the positive one. You could put a plus out in front, but you don't need it. But we would have gotten rid of the negative portion of this graph, because you'll notice if we don't, this will not be a function. Okay? So now that we've found the function, we're going to use this information to do a composition of the function to prove that they're functions. So I'm going to start off by doing f of f inverse of x, which would be my outside function is 3, parentheses, squared minus 6, and then I'm going to take my inverse and I'm going to put it inside, so x plus 6 over 3. Okay, so the first thing you have to keep in mind, you've got to show every single step, and the order with which you do this is very important. The first thing that can cancel out is going to be this square root and the square, leaving me with 3, parentheses, x plus 6 over 3 minus 6. And then the next thing that would cancel out would be the 3's, leaving me with x plus 6, so these would cancel, minus 6, and then I'd be left with x. Please remember, we will already know the answer. We have to show every single step to get to the answer because we are proving that's the answer. Okay, so given this, now my outside function is f inverse, so that means I got this, parentheses, plus 6. Make sure you get all this underneath the radical. Okay, otherwise you won't get to the correct place. Then I've got inside of my parentheses, I put 3x squared minus 6. Okay, so our first step in simplifying would be our 6's would become 0. So that would give me 3x squared over 3. And then my 3's would cancel, giving me the square root of x squared. And then the square root of x squared is x. So now you'll notice that we first up here found its inverse, and then we were asked to prove it through composition. Okay, so we're just going to try just a few more proofs because these can get, sometimes we get a little confused in what order to do what. So we're going to do g of f of x, and then we'll also do f of g of x. So if I do g of f of x, that means g is my outie function. So I'm going to do parentheses plus 7, and then the minus 2 is on the outside. It's always a good idea to go back and take a look and make sure you did it right. Then I'm going to take my f function and put it on the inside. So I got x plus 2 squared minus 7. Okay? To start simplifying, my first step, well, these 7's will become 0. So I've got the square root of x plus 2 squared minus 2. Now my square root, my radical and my 2 will cancel, leaving me with x plus 2 minus 2, which gives me an answer of x. So now I want to go the other way. Remember, if you're going to prove it, you're going to have to take it both ways. I'm going to do g of f of x. So, f of g of x. Sorry. It's not going to do me any good to do the exact same problem. Let's try that again. F of g of x is going to be, f is my outside function, so let's see. I've got x plus 2 squared. Notice I put brackets just because I've got that parentheses inside of there. And then I've got this minus 7 up here. So to double check, I'm going to go back and look. I got parentheses plus 2 squared minus 7. Okay. So now I want to take my g function. I'm going to put it on the inside. My g is the square root of x plus 7 minus 2. And then after that, I'm going to start simplifying one step at a time. So I would get, let's see, my 2's will cancel. So I'm left with x plus 7 squared minus 7. My radical and my squared will cancel. X plus 7 minus 7. And then I'm left with just x, which is exactly the answer we expect to get. Okay, we got one more practice problem. So, same idea, f of g of x. F is going to be my outside function, which means I got 1/2. I'll do parentheses minus 1 squared minus 3. And then I'm going to take my g, which is the square root of 2x plus 6 plus 1. And then I'm just going to start simplifying this. So let's see, the first thing that'll go away is those will become, my 1's will become 0. So I got 1/2 times the square root of 2x plus 6 squared minus 3. The next thing that'll go away will be my radical and my squared, leaving me with 2x plus 6 minus 3. The next thing would be 1/2 times 2 is x, 1/2 times 6 is 3 minus 3, and then I'm left with x. Once again, that is the expectation that is supposed to happen. So then I can do it the other way, which would be g of f of x. G would be my outie, so I would do this 2, I got these parentheses, plus 6, and then on the outside I got plus 1. On the inside of that I got to put all that stuff, so I got 1/2 x minus 1 squared minus 3. So let's see, where do we start? When I look at this, my 2 will multiply, I would distribute my 2 into my parentheses. Looks like I cluttered. 2 times this, remember this is one of my terms, so 2 times 1/2 would go away, so I'm left with just x minus 1 squared. And then I go all the way over to here, and it's 2 times negative 3, which would be negative 6, and then I still have this plus 6 plus 1. So now you'll notice how these 6's will cancel out. So I'm left with x minus 1 squared plus 1. My radicals and my square will cancel out. And then I'm left with x. Okay? Hope this helps. Come see me if you got any questions.